Assalamualaikum and a very good day everyone. My name is Isa Ali Imran bin Muhammad Zain and today I'm presenting my final year project for CSP 650 Infotainment for the requirements for Bachelor of Computer Science, Data Communication and Networking. The title of my project is Securing Home Networks DMZ with Deep Packet Inspection via Raspberry Pi. This project supervisor is Madam Nur Azilia binti Ahmad Azam. Firstly, I'm going to start by talking about the Internet of Things. And by that I mean the smart tech that is used in homes, which includes but not limited to the smart door lock, the smart light bulb, even smart vehicles. But unfortunately, security and the Internet of Things are not usually on the same page and are usually vulnerable and susceptible to attacks. This can and has caused incidents such as personal data leaks, invaded privacy, ransom attacks, and even can be weaponized and to be used to attack websites such as Twitter. Even so, IoT devices are amazing. Low-power IoT devices can assist mankind to a more technological advanced state, which includes making the lights turn off automatically when no one is around with a smart light bulb, changing the temperature of a room to better comfort the people in the room with a smart thermostat, and monitoring and detecting intruder with a smart camera. But unfortunately, these devices aren't safe until it's secured. So how do we secure it? Here's where my project comes in. In both utilizing DMZ and an open source DPI capable IDS, securing a network should be possible for everyone. Let's start with the objective of the project, shall we? So the first objective is to design an intrusion detection system using a deep packet inspection applicability for Raspberry Pi. And the second one is to develop intrusion detection system using deep packet inspection. And finally, to evaluate the performance of DMZ with intrusion detection system with deep packet inspection. The project scope covers the designing and adding the intrusion detection system that has deep packet inspection using real home network environment. This also entails installing an open source IDS and OS on the Raspberry Pi to detect any malicious packet. Raspberry Pi will also create its own network to act as a DMZ for the home network. The target audience for this project, or its significant, benefits home users that requires a cheap alternative to secure the IoT devices by creating a DMZ. Now, what's a DMZ? A DMZ, or a demilitarized zone, acts as a secondary network containing the network's exposed services. Services such as IoT, servers, and other devices that need unrestricted access to the internet. A DMZ works as part of the network that has little to no security. Why a DMZ is recommended? Because it is easy to implement with no to low cost. And it adds another extra layer of protection to the network. But a DMZ is a network just like any other, therefore it has the same vulnerability as the network. This brings me to Deep Packet Inspection, or DPI. What is DPI? DPI is a complete packet inspection or network packet filter that evaluates the data section of the packet. DPI works alongside IDS to filter and monitor traffic. DPI works by checking both the header and the data part of the packet and then alerting any packets that are compliant with the user predetermined rules. Compare that to the traditional packet analysis, which only checks the IP and the TCP. DPI also scans the application layer of the packet, hence making the monitoring more thorough and secure. So why do I choose DPI capable IDS as compared to other options such as the firewall? As we can see here, based on the table, DPI has the needed aspect of a security device, especially on analyzing traffic patterns and the way it works, which scans both the header and the data part of the packet. Next, we move on to the reasoning why I chose the Raspberry Pi. It's simple really. Because the Raspberry Pi is cheap, which means it's affordable. It's also highly supported by the online community, which means it's easy to get information to troubleshoot the device when an issue occurs. And finally, because it has good specification. The newest revision of the Raspberry Pi, which is the Raspberry Pi 4, as up to 8 gigs of RAM, which will help in the good performance of the IDS software later on. Alright, to start the project up, I would need to choose an open source IDS, a software that is capable of performing DPI on a low-powered device such as the Raspberry Pi. There are a few candidates for the IDS software based on the literature review I've made so far. Based on what I've researched, there is NDPI, Liprotoiden, L7 filter, and Snort. As for the selection process, the table can show the reasoning. As we can see here, Snort is a very good candidate based on the aspect it provides. Two very notable points are for the requirements of the hardware and the open sourceness of the software. Now that is sorted, so how am I expected to achieve this project to its maximum potential? For the methodology framework, I'll be using the Rapid Application Development Model. The reason for this approach is due to the function of the model, which replicates the design and implementation phase in a loop. The first phase will be the initiation phase. This phase will be the development of the project objective, problem statement, scope, and significance. Next will be the research phase. In the planning phase, a work breakdown structure is created to define the project scope in more detail. This phase also includes the requirement of the project. Next is the design phase. This phase is then divided into 3 sub-phases: hardware, software, and network design. The next phase is the implementation phase, which includes the hardware and the software installation and configuration. Next, we will move on to the testing. The whole system will be tested based on several goals. If those goals are achieved without any errors, then the system will be successfully deployed. And after that phase is done, it is for the evaluation phase. Finally, it's the documentation phase. Finally, the report is put forward for submission. Now that the methodology is sorted, let us move on to the development and testing. First things first, here is the network diagram of the testing. Based on Gartner.com, a leading security firm in IoT security, the frequent attacks of IoT devices are DDoS attack and port scanning attacks. So the project entails 3 types of attacks, which are TCP SYN flood attack, UDP SYN flood attack, and Nmap port scan attack. The tools used for these attacks are low orbit ion cannon and Nmap. Attacks are launched from different sets of IP address outside the home network to simulate the attack is coming outside the network. The attacker clients are 5 Windows VMware machines and 1 Kali Linux VMware machine, which is on the 192.168.10 network. The reason why there are 5 Windows 7 VMware machines is because LOIC has a limit of 99 simulated thread users, and the project will use up to 250 simulated threads. Therefore, 5 Windows 7 VMware machine is needed for the project. Next, the Kali Linux VMware machine will handle the Nmap port scanning attacks. Attacks will also be launched for a duration of 2 minutes, and the performance metrics will be recorded, such as the average CPU load of the Raspberry Pi, average memory usage of the Raspberry Pi, average latency of the devices in the DMZ, and finally the detection of attack by Snort. Now, let's move on to the IoT devices that will be the victims for the attack for this project. In this project, we will use 2 of this Xiaomi Yeelight light bulb, which is a smart light, 1 Dafang smart camera, which is a smart CCTV camera, always online CCTV camera, and 2 Xiaofang CCTV camera, which is a smart camera. Devices will be tested before and after IDS system is installed and the attack is launched. This is to prove that the Raspberry Pi can work as intended while running off-the-shelf product that is available in normal households. The project also requires a router application that allows the Raspberry Pi to create its own access point that will act as a DMZ for the network. The RASP AP is used for this project for its ease of use and deployment. It is configured to have a different set of IP address from the home network to emphasize more on the network becoming DMZ, and is isolated from the home network. Next, Snort is used to deploy on Raspberry Pi in inline mode and with its custom rule set to detect the attacks. Here's a short demonstration when the attack is detected. Now, when the attack are launched, Snort will display all the attack information as shown here. Now, for the result, all attacks are detected with snort implemented as shown here. When an attack is detected, snort will display the timestamp, priority of the attack, message set by the rule set, type of packet, and finally source and destination of the IP address of the attack. Now to evaluate the DMZ performance when the attack is launched. Here is a summary of the average CPU and memory usage for both SIM flood attacks. As shown in the figure here, there is a short spike when the attack is launched. This is because Snort is now running in the background and detecting whilst alerting the user of the attack. The next attacks afterward do not show any significant increase in resource usage because the rules used in this type of attacks does not require many resources from the Raspberry Pi. Next is the latency of the devices in the DMZ. As shown in the figure here, UDP SIM flood attacks requires way less threads compared to TCP flood attacks to overrun a network. This is because, unlike TCP, UDP does not require confirmation from the target, or they call it a handshake. Hence, they can send invalid requests that looks like legitimate requests. With that, a target can be easily overwhelmed by requests and ended up taking all the resources from the DMZ with lesser threats compared to the TCP SIM flood. On the port scanning attack, the performance hit of the DMZ is very little due to the fact that port scanning attacks are not continuous and will only hit once. CPU usage will increase when the attack is detected for a second or two and then go back to ideal resource usage state as shown here in the figure. Figure on the left is the CPU usage before the Nmap scanning, and figure on the right is the CPU usage after the Nmap scanning is done. Therefore, there won't be a performance difference on port scanning attack, and the DMZ will function perfectly during and after the attack. And that wraps up the development and testing of the project. In conclusion, every objective of the project has been fulfilled. There are few limitations when executing the project, primarily in which there are some attacks that are not equal as other attacks. This is referring to the difference of thread amount where UDP SIM flood attack require way less threads compared to TCP SIM flood attack to completely overwhelm a network. This shows that the home router used in this project is a bottleneck and can't handle more of the attack without affecting the devices in the DMZ. Among the things that recommended for the improvement for the project for future research is to increase the variety of attacks. Attacks chosen for this project were primarily to secure IoT devices. Variety changes such as securing a web server would bring in a different set of attacks such as cross-scripting attack and man-of-middle attacks, and that would increase the capability of the Raspberry Pi as a security device. All things considered, IoT devices are an amazing invention. Even with its security flaws and risks, people still use them daily and helps them throughout their lives. This project aims to secure IoT devices, making a whole lot more easier, affordable, and accessible for any home users that still want to keep using their IoT devices in a secure manner. That is all from me. My name is Isa Ali Imran bin Muhammad Zain, and thank you for taking your time to watch this presentation.